These are the notes for structure of the atom. Like we saw in the Ed puzzle, there are 3 different types of particles in the atom, and they are in 2 different locations. So we have electrons that are outside of the nucleus. They're in orbitals. They're very small and they have a negative charge. And then inside the nucleus, which is a clump of 2 types of particles in the center of the atom, we have protons, which are positively charged subatomic particles, and then neutrons that have a neutral charge. One way we can draw this is with a Bohr model, which shows the same information, that we have a clump of atoms or a clump of particles in the middle with these electrons orbiting on the outside. And we'll get into more detail as to how these electrons are positioned on these different rings. But for today, we're going to focus mostly on the particles in the center, which are protons and neutrons. And what we can do is we can count them just looking at protons, which are these black dots, or just looking at neutrons, which are the gray dots. And then if we count both of them together, then what we call that is the mass number. And we call it a mass number because these particles are much, much bigger than electrons, and they have more mass. And so when we measure the mass of an atom, most of that mass comes from these particles in the nucleus. In the periodic table of elements, each cell represents a different type of element, and it contains lots of information. So at the top, there is an atomic number, which is the number of protons in the atom. And this is different for every single type of element because the number of protons defines what type of element it is. Then in the middle, we have an element symbol, which is 1 or 2 letters. In this case, B stands for boron. And if there are 2 letters, then the second one is lowercase in the element symbol. And then at the bottom of the cell, we have the average atomic mass. And this number is a decimal because it is the average value for all the for all the atoms of this element. And so for today's homework, we're going to be rounding it. But later in this unit, when we talk about isotopes, we'll talk about why this is not a whole number. So your homework will look like this. We're going to try to put information in this table at the bottom, and in order to fill that table in, we're going to look at the periodic table of elements here at the top. And so for the first element, we have helium. Helium is in the top right corner of our periodic table, and if I zoom in a little bit on that cell, we can see that it has a 2 at the top and then a 4.003 at the bottom. And so we're going to take that 4.003 and we're going to round that to 4 for our mass number. That information is already in the table. We've got helium, the symbol, the atomic number of 2, and the mass number of 4. For the number of protons, we are going to match that to the atomic number because that's what the atomic number represents. It's the number of protons. We are also going to match that for the number of electrons today. And later in the unit, we'll talk about ions, where the electrons and the protons might not match, but today they will be the same as the atomic number. Then for the number of neutrons here in the middle, we're going to have to take the mass number, which we found at the top was 4, and then subtract the number of protons to find out how many neutrons are there. So in this case, there are 2 neutrons, but that is not the same as this 2. It's coincidentally equal. For our next row of our table, we're looking at bromine. And bromine has a symbol of Br. So we can go look at the periodic table, and we can find that Br is over here on the right side of our table. If we zoom in on that cell, we can see that the atomic number is 35 and the mass number is 79.904, which we can then round to 80. So we have an atomic number of 35 and a mass number of 80. We already have the mass number, but the atomic number is not in our table yet, so we can add that. And then we can copy that same number for protons and electrons, which already is there. For the mass number, we're going to have to do that math. Or excuse me, for the neutrons, we have to do the math. So the number of neutrons is equal to the mass number minus the number of protons. And so our mass number for bromine is 80, and our number of protons is 35. The difference is 45, which is how many neutrons we have. And so now we can see that the number of neutrons and protons is not equal, and that is pretty common for them to be not equal. For our last element, we don't have the name or the symbol, but we do have the atomic number. So the atomic number is the number at the top of the cell. If we go look at the periodic table, we're looking for the number 30, which, come on, is right there. And so the element that we're looking at is zinc, which has an atomic number of 30 and a mass number of 65 once we round it. So I'll write the name zinc and the symbol, which is Zn. And then we can match the atomic number to the number of protons and the number of electrons. And for the number of neutrons, we're going to take the mass number of 65 and minus the number of protons, which is 30, to get 35 neutrons. Thank you very much for watching.